Quote from a book on design for manufacture. This is a systematic process for designing products or modifying the design so they are easy and inexpensive to produce. In this video, I'm going to share a story on how we brought innovation to a PC maker. Not in a glamorous area like the CPU or the GPU, but in a super mundane area of the metal enclosure of a desktop PC. Let's get started. Most desktop PCs still come in a 20 or 25 liter chassis, and most of the chassis remain pretty much empty and only a fraction of customers put the expansion cards in. So one could challenge the overall product architecture, but this is not the topic of this video. So let's assume that the big box is required. The weird thing about desktop PCs is the way the product innovates. While all electronic components undergoing revolution after revolution, and the product made today is orders of magnitude more capable and powerful than a product made 30 years ago, the making of the chassis has not really changed. It is still a heavy metal box held together by rivets and screws. Let's look at the process of making the enclosure in detail. The images I am showing you are borrowed from the YouTube channels of BBS Customs and Demi, and I recommend you watch their full-length videos. Leave a like and subscribe. For obvious reasons, I cannot show you the actual images from my client, but what you will see is close enough to what happened there. It all starts with a strip of steel that unrolls from a coil. The strip is fed into a series of stamping presses with progressive tools. At each step of the process, the individual parts of the chassis come closer and closer to the final shape. Next, the parts are put on hangers and are fed into a paint line. The paint can be applied manually as shown here, or by robots in bigger factories. Then the parts are put into storage. And finally, the painted parts are assembled into the desktop chassis. This is done by inserting on average 80 rivets and screws. This is how desktop chassis were built in the 1980s, and this is how desktop PC chassis are built today. The biggest problem with this production process is that it is highly labor intensive. You have seen the many parts that need to be handled and the packing and unpacking. And of course we have the manual process of inserting the rivets and screws. The rivets and screws pose an additional problem. 80 times you have to hold your breath and hope that the operator does not miss the hole in which the rivet or screw is meant to go. If the operator misses, the already painted chassis will be scratched. You may get away with a scratch that is inside the chassis, but the scratch on the outside requires expensive rework. If you are the procurement person responsible for the desktop chassis, there's only so much you can do. Of course you can try to squeeze the supplier, but labor costs are bound to increase. So rather than squeezing the supplier, we went back to the drawing board. We asked ourselves how a contemporary process for making a desktop chassis would look like. We wanted to eliminate rivets and screws, and we wanted to have as few parts as possible. In the end, we completely changed the geometry of the parts making up the chassis. The new process was mostly continuous, and it involved a lot of bending and some welding. Again, what you see here is not exactly the solution we came up with, but it gives you a rough idea. And just to clarify, this was not procurement executing an initiative driven by engineering, this was the other way around. An initiative conceived by procurement and executed by engineering. So there you have it, D7 Design for Manufacture, a purchasing chessboard method that aims at making life substantially easier for your suppliers. Okay, now it is your turn. In the comments down below, let all of us know if you have a cool example for Design for Manufacture to share. Should you have a question, I will get back to you within 24 hours. Thank you for watching, and I see you in the next one. Bye!